Furthermore, cleaning the wafer to wash away dust particles that may have landed on the wafer, as well as inspecting the wafer to make sure everything is being built properly, happens frequently, and these steps need to be added to the circle. A different tool is used to complete each of these process steps. Now that we have an understanding of the steps, let's take a look at this semiconductor fabrication plant. This CPU is manufactured on a 300mm silicon wafer, which can fit 230 CPU chips. In contrast, DRAM chips are considerably smaller, and thus 952 of them can fit on a wafer. These silicon wafers are carried in stacks of 25 using a container called a front opening universal pod, or FOUP. This sealed plastic wafer carrier is transported around the cleanroom floor using an overhead transport system which lowers the FOUP onto the tool's landing pad. Inside the tool, robotic arms transport the wafer through vacuum load locks and to different process chambers where materials are added, removed, or processed in ways that we'll explore later. The wafers are then returned to the FOUP, resealed inside, lifted up to the overhead transport system, and carried to and dropped onto the next tool, where the next step in the process is completed. To build the entire chip composed of 80 different layers, it takes 3 months of traveling from tool to tool, where at each stop one of the 940 process steps is completed. In order to increase the microchip mass production capabilities of a semiconductor fabrication plant, or fab, typically there are dozens of the same semiconductor tools organized in rows that perform the same process.